Hello, happy Saturday. I had gotten a request to go over chapter 5, problems 7 through 9. And so here's a video of me doing that, solving them in R. Okay, so this question first starts about how presenting suicide is important issue facing mental health workers, predicting which geographic regions where the risk of suicide is high could help people to decide where to increase or improve mental health resources and care. Some psychiatrists have argued that homicide and suicide may have causes in common. If so, one would expect homicide and suicide rates to be correlated. And if this is true, areas with high rates of homicide might be predicted to have high rates of suicide. So we're having the homicides predict the suicides, right? Homicides would be our X and suicides would be our Y. And therefore be in need of mental health resources. Research had mixed results, however, including some evidence that there is a positive correlation in certain European countries, but not in the US. So here's data for 2015 and for 11 counties in Ohio with sufficient data for homicides and suicides to allow for estimating rates for both. And the rates are per 100,000 people. So in Butler County, there's 4 homicides per 100,000 people is how we interpret this. So we want to make a scatter plot that shows how the suicide rate can be predicted from homicide rate. There's a weak linear relationship, so we really wouldn't want to use this as a predictor, but it's homework, so here we are. With our R as a negative 0.06, that's very weak and very small. So I want us to find the least squares regression line for predicting suicide rate from homicide rate. So our suicide rate would be A, which is our y-intercept, plus B, our slope, times the homicide rate. Remember, our slope is not our coefficient of correlation. So let's go ahead and download our code, right? I downloaded it as a CSV, and then I go into R. And the first thing I want to do is I lost me. Hi. The first thing I need to do is call in that data file. I thought this would make it so you could see me. Apparently not. Okay, well, so much for seeing me. Okay, so what we're going to do is we're going to go ahead and run this data file, right? So I'm loading it into R. Once I do that, I could take a look at it, see what it's made up of, and see the entire data set. That's exactly what they gave us in Achieve. So to find the least squared regression line, we're going to use the code LM. LM means linear model. So this will give you your equation for your best fit line. So I'm going to do LM of deaths and then by suicide and then deaths by homicide, because we always put our Y variable before our X variable. So that would give me a coefficient of 14.036 and a slope of negative 0.049. Now if I wanted to, I could calculate the correlation coefficient. That's because I spelled it wrong. Let's try that, right? There we have that weak correlation. If I wanted to, I could plot this scatter plot to see like, oh yeah, this is really weak, but probably negative. But this was what it wanted, right? So we can go back into Achieve, and we can put in our intercept, which was 14.306. So that would be like our predicted homicide rate if there were no our predicted suicide rate if there were no homicides, and then our B was negative 0.049. And then we can check our answer, and that was correct. Cool. So let's take a look at the next question. So we need to interpret the slope, right? We want to check our answer. So the slope means that for every additional homicide, there's an average increase of 0.04. That's not going to be it because it's not increasing, it's decreasing. We can ignore any of the ones with slope, right? The slope doesn't affect the suicide rate, right? we can ignore any of the ones with the y-intercept, right? That's if our homicide rate is 0, right? That's not changing, you know, for every additional homicide, there's an increase of 14.306. No, what it is that for every homicide, the suicide rate is going down by 0.049. Because if you look at our slope, right, it's a downhill slope. So that means that for every homicide, the number of suicides is decreasing. So we'll go back to achieve and check that. Awesome. Next question. So another Ohio county, not in this data, has a homicide rate of 8 per 100,000 people, and we want to predict their suicide rate. So we're going to give our answer to 3 decimal places. So this output tells us that we have, this output tells us that we've got our intercept of 14.306, we've got our slope of negative 0.049. So that means that suicides equals 14.309, that's our y-intercept, minus 0.49 times homicides. We're using homicides to predict suicides. So to solve this equation, we're going to substitute in 8 for homicides. So I took 14.306 minus 0.049 times 8. That gives me a 13.914, and I can go ahead and put that into Achieve and check our answer. And we are again correct. So hopefully that helps you see how you can download data from Achieve and use it and answer any questions you may have had about problems 7 through 9.